Let's take a closer look at our second topic, and that's how do you actually get to a professional setup? Because it's cool that we talk about the business reasons and the benefits for the engineers, but what is it that makes it a professional setup? And how Hyman and I came to talk was, one of the reasons was because he published a really nice article in which he had a super rich image, I would call it a spider web of things, foundational pieces that teams need to take into account or need to focus on. And it would be nice, Hyman, if you can guide us through, at a high level, some of these foundational pieces that teams need to focus on when setting up Kubernetes at scale. And probably the audience can see the image as well.
Yeah, this is the image that I shared. When you implement Kubernetes, that's not it. And a lot of people who implement Kubernetes think it is. So if you implement Kubernetes and you just click through the Azure portal or the AWS portal or any portal at all from any cloud provider, you will have a Kubernetes cluster ready to go within 5 minutes. That's fine. You can use development for that. You can experiment with that. But in order to be production ready, there's a lot of stuff that needs to happen to make it production ready. So that's why I created this image, maybe a year ago already, to sort of draw the dependencies of what you actually need to make it production ready. And this is just the basics, because there's a lot more, but it wouldn't fit in one image. So if we think about the basics, and maybe we can walk through each of them.
Yep.
Maybe the first of all, of course, if you run Kubernetes, you need infrastructure because you're going to run a container, at least one on Kubernetes. Otherwise, you wouldn't need Kubernetes. So you would need a container registry in order to put your containers and push your containers to an Azure container registry or one of AWS. You need to set up your DNS, your load balancing. You need to think about your IP addresses, your networking range. Make sure that it's entirely private, because if you set up Kubernetes by default, it's not secure. A lot of people underestimate that because Kubernetes is not secure by default. By default, if you click through the port when you create an Azure cluster, an AWS cluster, it has a public API. And people don't know that, but there's a lot of people don't know that. And they just create a publicly facing Kubernetes cluster. Yeah. You need to think about your networking stack, a VPN, how can developers securely access your Kubernetes cluster. All that you need to do from an infrastructure perspective. And you can click all that through the portal. But in general, I have one philosophy, and that is do not ever click in a portal for your production workloads. Do everything as code.
And why is that? Can you elaborate a little bit on why you would like to do that as code rather than just clicking it one by one in the portal?
Yeah. So first of all, developers and engineers like I am, I forget what I did at least a year back. So maybe last week I did some things that I already forgot. That's one thing. So if you forget something. You click something somewhere and there's a Kubernetes cluster. You might have done a network peering manually and you forgot about it. Or you might have set a rule open for the internet, for example. You might have forgotten about it. And that happens a lot. So code makes sure that everything is traceable. You can put it in Git, everyone can see it. If the engineer leaves, someone else can take over and see what is there. And using declarative infrastructure, like Terraform, for example, it's an example technology. If you use declarative infrastructure, you specify what needs to happen. And you can run the apply sort of every single time over and over again. So if someone changes something in the cloud, which should not happen because everything should be done through code, you can see that immediately with your next Terraform apply, for example, if you're using Terraform. And there are so many other advantages, but I think this is the main one for using.
So would you say, hey, if you just start and you want to familiarize yourself doing it through the UI of whatever, AWS or Azure GCP, that's perfectly fine. But as soon as you think about it for a minute to really push this to production, then you actually say, hey, the infrastructure as code, to have that super repeatable, controllable, that's really important.
Exactly.
Yeah. And from my own experience, working for ING, it's quite a couple years ago, but also from a compliance perspective, that is important. You mentioned that you can trace every change and just applying good coding practices with reviews, storing the changes, if you like, having that over time is really important because, application and infra are in that way blending together, and then having the full track of your entire stack is super important. Yeah,
Exactly. Yeah.
Cool. But we're derailing a little bit from the image here. What are a couple other important elements from the spider we would like to talk about?
Yeah, so the second one from the image is the monitoring and logging and decentralized observability. So whenever you install Kubernetes and the resources you need to make it run, basically, because that's what you use infrastructure as code for, then you will need to do stuff within Kubernetes to make Kubernetes and to make your experience for your developers as good as possible. So the way you do that is introducing centralized monitoring, centralized logging, make sure you have dashboards that developers can use. Make sure your logging is centralized and the developers have a visualization for that logging. For some companies, tracing is a really important one. If you run microservices, for example, you might want to see your performance bottlenecks in between the different services. And the whole observability aspect is really important to make it production ready.
Yeah.
So for development, you wouldn't need it at all, probably.
Yeah.
Sometimes you still need it for development, but for production it's actually necessary.
There's no need to convince me on observability or troubleshooting. We're talking here with StackState, and actually, if I can make a little promo, we do observability for Kubernetes at scale, and in particular, we really aim for helping out software developers to become effective in troubleshooting. So, in particular, this orange. Is our bread and butter, I would say. And if you need to pick out, for example, security and authentication, I can imagine that is pretty hard because the infra, observability, releases, and development, these are kind of the four angles that every engineer would know. If you want to get a working app in production where customers can have access to, well, these four are super important. But then the security and the authentication, I do believe, are a little harder and a little bit more abstract. Can you guide us a little bit through what does that mean to do this professionally at scale? Yeah,
so what you need to think about first is the principle of least privilege. It's hard to pronounce that. The principle of least privilege is like it's a principle where you only give people access of what they need. So if you have developers that probably don't need admin access for your Kubernetes cluster, you can give them access to a particular namespace, or you could give them access to certain access for production that they don't have, for acceptance that they don't have in a production environment, for example. And all these things you need to think about from an identity and access management perspective, your role-based access control. The clouds have their centralized role-based access control, and you can use that to also connect it to Kubernetes, so that developers that are using the kubectl API, the Kubernetes API, that they are, for example, not allowed to delete something in production, or to deploy something in production.
Just to query and get information from an observability perspective, for example, how does my application run and whatever, how's the scaling going and these type of things, rather than creating or deleting, changing stuff there.
Yeah, because especially because you mentioned bigger companies, usually you'll have a compliance and risk department. Yeah. If you're a big enterprise, you'll have maybe risk and legal and compliance officer, and they will really want to know about who has access to production. And before something is rolled out to production, who has looked at it, who has verified it, and how can we make sure that everything works well and is really secure. And those are all compliance things that you need to think about. And yeah, from a security and authentication perspective, this should be at least managed centrally. And not, well, so Kubernetes has role-based access control, and in the cloud you can link that to your groups and to your roles within the cloud. Yeah. And make sure that the developers and the engineers and the SREs only have the access they need. Yeah.
And do you then also see kind of a separation of concerns between the engineers pushing and deploying their apps and the platform team and the SRE team? So do you there see, I can imagine the platform team has a bit more access, needs to sign a bit more papers to do so, versus the developer. So do you there see that clear distinction?
Yeah. Yeah, in general I do. So it depends on the question someone asked before. If developers are managing their own cluster, which is also a strategy, then they need more access because they need to be able to recreate their cluster if things go bad or go sideways. So that is something then they would need the access for. Yeah. But in general, the principle still applies: is if you don't need the access, you shouldn't get it. But also, there should not be one person in the organization that has admin access, because if he is asleep or maybe sick, then
Yeah,
someone
on
else should be
holiday.
able to take over.
Exactly.
Yeah.
Yeah, and that's also where the infrastructure as code, right, or the entire definition of the cluster as code is so freaking important. If someone leaves or gets sick or whatever, you need to repeat it, right? Then just executing whatever is specified in code will generate a full new setup, and you can go there again. Hey, why did you split the security and the authentication into two different arms? Can you help me understand a little bit better what is kind of the distinction and why to focus on both?
Maybe because it looked nicer. Maybe because I needed 6. So security and authentication are really related, of course. Secret management is sort of different, which is also within the security sphere in this diagram. Secret synchronization is really important. So especially if you're using modern GitOps deployment techniques for Kubernetes, you don't want to put your secrets in Git, and you want to make sure that people only have access to the secrets they need, and maybe don't have access to secrets in production, for example. And you should do that with like an externalized secret synchronization tool, like external secrets, for example. And that works really well. So you can you can centrally manage your secret in Key Vaults or AWS secret managers, or HashiCorp Vault or something like that, and then sync them into your Kubernetes cluster whenever you need them.
Yeah, cool. Yeah. Hey, one of the blog posts that you wrote a while ago was with a reference architecture, and I do know reference architectures are really good to understand, and probably we can bring it up here. And the interesting thing that I do think is in the reference architecture, and that's probably how you can talk us through, is you see that really nice combination of the elements that you've mentioned above, right? The observability, the deployment, release, the vault or security. How does that relate here to this reference architecture?
Yeah, so this is an example diagram that we usually use as a basis at Pioneer. There's a lot more stuff involved to make a production-ready cluster, and that depends on the client. So some clients need the ELK stack, for example, for centralized login because they're way bigger. But this is in general I believe, a really good architecture to start with. So from a monitoring perspective, you can think about Grafana, Prometheus, Thanos, and have those tools, sort of do your, and Loki do your logging, your metrics.
And I do think Prometheus and Grafana is known to everyone. I know Thanos. What is Thanos?
Yeah, Thanos is a tool that is mainly known for long-term storage and really big monitoring systems. So Thanos looks at different Prometheus instances and sort of gives you a single pane of glass for Grafana to look at all your metrics. And it's also able to store data in the cloud. So what we do at Pioneer, we have a disaster recovery strategy of just throw the cluster away and recreate it. Yeah. And then all the data should be outside of the cluster, or persisted somewhere in the persistence cluster with state. And with Thanos, we can do that with the metrics, and we put all the metrics in the cloud. And it goes back to 10 years, I think. So even if you want to go back to 3-4 years ago, what happened there, or see certain patterns in your monitoring, with Thanos you can do that. Prometheus is just short-term storage. So, and then just for the audience to really understand, so if we talk about metrics here, we talk about IT metrics. We talk about system metrics. Here we don't talk about the business metrics, about the transactions of the business, but we really talk about I'm observing my microservices. I'm monitoring that with Prometheus and having dashboards with Grafana, right, to visualize. And then some of these metrics you want to store for a longer period of time. Let's say seasonality, what's happening around Christmas, or all these famous examples, or attacks, or whatever. You want to store that longer term, and that's why you use Thanos for, because Prometheus most of the time just stores it for 2 weeks or something like that. And Thanos can even store all your metrics, but with higher intervals. So of course Prometheus scrapes every few seconds. And with Thanos you can say everything that's older than 30 days, I only scrape once a minute, for example. And then, so your data in the cloud doesn't go up that much. Well, you still have all the information you need from a long-term perspective.
And then there are a couple alternatives. I mean, we're having here Thanos, but there's M3DB, there's Victoria Metrics as two alternatives. And then with StackState, we also use Victoria Metrics under the hood to exactly solve this problem. So the longer-term data storage compared to Prometheus short-term. Hey, what are kind of two other elements from a security or authentication that are important in this reference architecture?
Yeah, I think from a security perspective, you can see the difference between the red lines and the green lines on the left. So what we generally do is make sure you have an internal load balancer for your internal services that is not accessible by anyone else except for your developers. For example, your Prometheus or your Grafana or Argo CD, they have an endpoint, right? And that endpoint should not be accessible for the public to access. So if Argo CD gets hacked and someone would be able to, well, infiltrate, basically, in that case, well, you have an extra layer of security, making sure only users with VPN access will be able to access that application. Yeah. And for your public application, you will have a separate Nginx or Traefik or whatever ingress controller you use for Kubernetes. But it's really good to separate those two. Yeah. And then that's from a security perspective really important.
Yeah, fascinating. I have never, well, I've probably seen many of these images, but never did that math in my mind to think that through indeed a little deeper. Hey, and this is an EKS cluster. I can imagine you can do this for every variant that's out there in the wild. And
these are just examples. I also put Microsoft Teams in there.
Could be Slack.
You can use Slack. You can use PagerDuty. Yeah, something like that. Yeah. And then the alert manager will notify you. That's actually a really important point of monitoring, because monitoring fatigue is an actual concept. So when developers or SREs or platform engineers are really fatigued because their monitoring just keeps on sending notifications, at a certain point in time you don't look at them anymore. And then a production incident happens and they keep asleep. And
so what I just a funny example, what I always tell my engineering teams when I was still leading engineering teams is I said, I want you have all your monitoring output, your alerting, go into your regular channel, right? Your regular development channel where you speak day to day with each other in Slack in our situation. And then they complain, but that it will be a lot of noise, right? And then the challenge I think teams should go through is tune the monitors, right? Or the alerts that much, right? That they come to a level that almost every signal that's outputted is valuable and meaningful and pay attention to. So just going through the pain and not creating a separate Slack channel or a Teams channel to push all the alerts into can be a way for, probably for all of you to grow and go to that pain.
Exactly. What we usually tell people is if you get an alert, you have to react. So you have to. So if you get it in Slack, you have to put a reaction beneath it. I looked at this, and it's probably not necessary to look at it. But at least it gives people the need to look at alerts. And if they get frustrated by the alerts, well, you have to tweak it. All
right.